Hi everybody, welcome to the video about citizen science for on-farm testing. We're going to talk about the following topics. Why is on-farm testing so important? Why is it so difficult? It is very difficult, but also citizen science can help, and we'll talk about how this can be. So why is on-farm testing so important? Well, the first reason is that we really want to know how varieties do on farms. It's not enough to know how they do on stations. Farms are different many times. And we also want to know what farmers and other end users think about them, including consumers and maybe processors and other people that are involved in crop production. The second reason, or the second area for reasons why to do on-farm testing is we want to already start exposing farmers to new varieties as a kind of a start of the variety dissemination process, and also engaging extension workers around these varieties so that we are sure that they will be successful and disseminated in the seed system. And then the third area is really the analytics. So we want to know whether certain varieties will be adopted, whether there will be seed sales if we launch them. We want to know how much genetic gain there is. So how big is the difference between the previous generation of varieties, and also all this feedback information will help to improve the breeding process. But it's also very difficult. So on-farm testing is not easy because conventional formats, so how participatory variety selection is done very often, uses fairly complex formats. Plots that need supervision from agronomists, that need instruction to farmers. Farmers need to be organized, and that is a second area where there's also a lot of coordination needed to organize farmers, to get the seeds to the field on time, etc. So there are a few of these issues that can be solved with what we call citizen science. So citizen science is not something that is only done for on-farm testing. So as an example, a big example for bird watching, where people use digital tools to do bird watching, then generate data that is also then used by scientists. And we've been really inspired by this example to also develop similar solutions for the agricultural sciences. In bird ecology, this is really successful. Most of the data that is being used is coming from volunteers, not from professional scientists. And that has been made possible by this huge investment in building nice digital tools and also providing a good service to citizen scientists. So the volunteers that generated data, they can use very nice apps to do this, and that makes it very attractive to participate in research and share data about bird observations in this case. So what about agriculture? So for agriculture, we can do the same. And it means these kind of four things. So we need to have a format where farmers are really motivated as citizen scientists. So they don't need to have large incentives and to become organized in these trials. They really participate as volunteers with their own efforts, using their own farm to do the tests. That needs a very simple format. So we need to make it simple so that farmers really can do the test themselves. They can feel confident in doing it, understand it. It also means, like in the bird example, that we need to go digital, so make much more use of digital tools. And also, because of the different formats, we need to have appropriate statistics that can really deal with the types of data that the farmers themselves are able to generate. So this, in conclusion, is the four things that we need to make citizen science successful for on-farm testing. And in the other videos, we'll see different elements of how this becomes possible with the tricot approach, the triadic comparisons of technologies or technology options approach for citizen science. So thank you, and I hope you'll enjoy the rest of the videos as well.